welcome all of you to the today's session. Good morning all of you. Hope you are doing well. So I've been discussing about environmental engineering. It is a revision class it is actually. So I've been doing it for the past 3-4 days. Okay, let us continue where we left yesterday. So we've been discussing about water demands, right? So water demands, per capita water demand also very important. The per capita water demand usually varies anywhere between 270 to 335 LPCD. That's what we discussed in the last class, right? Which includes domestic water demand, which includes industrial water demand, institutional and commercial water demand, demand for public utility, then fire demand, and as well as the demand to compensate losses and theft. So all of them put together, it comes around 270 to 335 LPCD. And this we evaluated as per IS 1172, as per IS code. I don't remember exactly the name of the number of the code. IS 11 something. Okay. So as per that, so total demand is normally 270 to 335 LPCD. In that, domestic water demand usually 135 to 200 LPCD. For low income grade people, it should be anywhere around 135 LPCD, slightly greater than or equal to 135 LPCD. If it is high income group people, they require more 200 or even more than 200. If we provide more water, we appreciate, but it should not be at any cost less than 135 LPCD, especially for Indian cities where populations are more than 1 lakh. Okay, populations less than 1 lakh, even some small towns and all, even slightly less also, it's okay, because everywhere you don't find a full flushing system throughout the city. So cities with full flushing system, we need to provide more water. Cities with a partial flushing system, even little less also okay, can do. But normally it vary anywhere between 135 to 200 LPCD. Okay, domestic water demand. Industrial water demand, a minimum of 50 LPCD need to be provided. Similarly, institutional and commercial water demand. So we need to consider the institutes which are already working in the community, and as well as institutes which are likely to come up in the near future also taken into account. A minimum of 20 LPCD need to be provided. Then demand for public utility. So we provide around 10 LPCD. Then fire demand, normally usually we work out by empirical formula that we had not discussed. So let us discuss about fire demand. What are the empirical formula used to estimate fire demand? So estimation of fire demand. So we have empirical formula. So using this empirical formula we work out fire demand. Following empirical formula are used. To estimate fire demand. The first one is Kuchling's formula, where Q is equal to 3182 root P. This is called Kuchling formula. So you need not remember, if at all they ask any question, they will give you formula. Then what you need to know is what is what in that formula is supposed to know. Because empirical formula you don't have any freedom. So whichever unit system you told to substitute the things, the same unit system is supposed to do substitute. Then only you realize proper answer. Otherwise you will go wrong. So Q is equal to 1136 into P by 5 plus 10. This is called Freeman's formula. And the best among all these formula is third one. Q is equal to 4637 root P into 1 minus 0.01 root P. 4637 root P into 1 minus 0.01 root P. So this is National Board of Fire Underwriters formula. This is an insurance company in US. So you want to claim the damages during the fire accidents, there must be a provision by using this formula. National Board of Fire Underwriters formula this is. So this formula should be used in estimating the fire demand, then only your claims are entertained, otherwise they don't entertain. P is equal to 5663 root P. This is called Buston's formula. In all this formula, Q and P carry same meaning. This is Buston's formula. So in all this formula, Q is known as fire demand in LPM. LPM stands for what? Liters per minute. Fire demand we work out in liters per minute. And where P is equal to population in thousands. Population we need to substitute in thousands. Suppose for 1 lakh population is given, 1 lakh you can't substitute. 1 lakh is equal to 100,000. 100 you are supposed to substitute. Population in thousands you have to substitute. Then you arrive straight away fire demand in LPM. Okay? So LPM you get, but we express in LPCD. Then how to convert LPM into LPCD? So you have to use your common sense. You have to use proper procedure to work it out. Suppose for example a question being asked, estimate fire demand in LPCD. Say town with the population 1 lakh. Okay, a town with the population 1 lakh. About 1 minute. So example, estimate fire demand for a town with a population 1 lakh using National Board of Underwriters formula. In LPCD, assume one fire accident occur per a month. So which lasts for 5 hours to extinguish, or which take 5 hours to extinguish the fire. That means the usual practice here is whenever fire accident occur, we not only issue water on burning property, we also issue water on either side adjacent to burning property as a precautionary measure. So therefore it requires huge amount of water. Normally we draw water, so normally we use 3 jets of water. Each jet issue water at a rate 1500 LPM for a period of 4 to 5 hours. So in that much time it will take to put out the fire completely whenever big fire accident occur. So at that rate, and that too the water applied with very high pressure, at a pressure of 10 to 15 meters head of water. So if you draw that water from the water supply system at that rate for that time period with that pressure, so all of the water is being used only to put out the fire, to extinguish the fire. No water left in the system. to meet other demands, then it is a bad system, isn't it? Whenever even 5 demand occur, you should not compromise other demands. Other demands also we need to meet. So there must be a provision. That's why it is also taken into account. So though it is not a regular demand, once in a while it happens. So every accident accident has got certain frequency. Once in a while it happens. Since in this question he mentioned that one fire accident per month. And this during that firefighting, how much time it will take? 5 hours it will take. That means 5 hours we need to apply water. Okay? So first we work out fire demand in LPM, liters per minute. Per minute that many liters are required. Then you multiply that value with 5 hours. 5 hours time it requires. 5 hours means almost 5 into 60, 300 minutes. Per minute that much water. In 300 minutes how much water we apply. So total water used in fire, in extinguishing the fire by the number of days once in a while this fire accident occur, that will give fire demand in LPCD. So you have been asked to work out in LPCD. So therefore there is no other option left with you. So one fire accident occur per month which takes fire for 5 hours to extinguish fire. So this simple question, 1 mark question only. Last year Karnataka state government exam this question is been asked. Okay. So fire demand in LPM is equal to, first let us work out fire demand in LPM by National Board of Fire Underwriters formula. Then we will work out so fire demand by using National Board of Underwriters formula is equal to, it is 4637 root P into 1 minus 0.01 root P. So where P is given as 1 lakh population. So 1 lakh is equal to how many thousands? It is 100 thousands, because we need to substitute this value in thousands. So therefore Q is equal to 4637 into root 100. So 1 minus 0.01 into root 100. Root 100 means 10 it is. So 1 minus 0.01 into 10. It is 0.9. Work out all of you 0.01 into 10. So it is 0.9 again into 10 into 4637. So I got 41,733 liters per minute. Okay, this is a fire demand by National Board of Fire Underwriters formula. So fire demand in LPCD is equal to, so total water used in extinguish the fire, total amount of water used in extinguishing fire by population of that community into frequency of fire occurring. Frequency normally we substitute in days. Okay, frequency of fire accident. Once in how many days it occur. So if you see that, take this one, then you can calculate. See now. So total amount of water required to extinguish the fire is equal to, so what is total amount of water required? Water required to extinguish fire. Fire is equal to, so fire demand in LPM, fire demand in liters per minute into number of minutes time required to extinguish fire, time taken to put out the fire. Time taken, this is substitute in minutes. Therefore what happens? This minutes get cancelled, left with liters, so also liters. So therefore I got 41,733. So I got 41,733 liters per minute. So fire accident occur 5 hours. 5 hours is how many minutes? 5 into 60 minutes. By population of that community is 1 lakh. Into frequency of fire accident is once in 30 days. Once in a month. Average 30 days. So this is in liters. This is persons. Unit 2. This is days. Then what happens? You get fire demand in liters per person per day. Nothing but LPCD you will get. Come on. Liters per person per day is nothing but LPCD. 41,733 into 5 into 60 divided by 1 lakh into 30. So normally we discussed it comes around anywhere between 4 to 6 liters. So I got 4.173 LPCD. 4.173 LPCD. So this is how we can work out. You can round it to 4.2. You can round this value to 4.2 LPCD. So when compared to other demands, it is very less because it is not a regular one. Once in a while it happens. That is how you can work out fire demand in LPCD. Okay. So the usual practice is whenever fire accident occur, how they extinguish the fire? They use 3 jets of water. So this is a fire. The fire is caught up. This is a fire. So 3 jets will be issued. 1 jet will be issuing water on burning property. This is a jet. Jet issuing water on burning property. Other 2 jets will be issuing water on either side adjacent to burning property. So other properties also on adjacent sides, they issue water. These are the jets issuing water. This is also issuing water. This is also issuing water. So 3 jets. At what rate? Usually they issue 1500 liters per minute. For how long it issue? 4 to 5 hours. 4 to 5 hours time it will take to issue water. 4 to 5 hours at a pressure, how much? 10 to 15 meters head. So at this rate, if you issue water, all water is used only to put out the fire. These are the jets. Jets issuing water. So 3 jets are used. 1 jet is issuing on, this is burning property. Other 2 jets are issuing on either side adjacent to burning property. These are the adjacent properties. These are adjacent property, these are adjacent property. This is the usual practice during fire accident. So 3 jets, so much water it consumes, but it is not regular demand. Once in a while it happens. Therefore, so demand is very less compared to other demands. So it may be 4 to 6 liters you have to keep aside every day with you till that fire break out in a community. Once it happens, immediately that water we can drop and use it without compromising the other demands. That is how we meet other demands, fire demand along with other demands. So we should not compromise on any other demand while serving the public. So every demand is very important. Okay? Then only it is a good system, scientific system. That's it. I hope it is clear to you. So one is burning property. On either side to burning property, adjacent properties also, we wet them so that it will not spread. So we can prevent the spread of fire. So that's how we can combat the fire accidents. Okay? So firefighting department is there. They will take care of this. But for them, what is required? Water is required. So we have to provide water to them. So they will take care of that is extinguishing part. Okay? Firefighting personnel, they rush to this part. Immediately they start issuing water on burning property. Not only on burning property, on either side adjacent to burning property at a rate 1500 liters per minute for a period 4 to 5 hours with very high pressure at a pressure 10 to 15 meters head of water. So that's how they work out the fire demand. Okay? I hope it is clear to you now. So population into per capita water demand, including all these demands, if you multiply, then what happens? We get total water required to be managed by the water supply system for that community. So that community every day it has to manage that much amount of water to meet all the demands to that public. So that public, no one is affected. So when they need water immediately, water should be available to them. Okay, then only it is a good system. Otherwise it is a bad system. It is a poor system otherwise. समझ गए भैया? भाई लोग समझ गए? Okay. Let us go ahead with the next topic, last topic here in this introduction. Design period. So already we discussed about design period. Design period is nothing but future period for which provision is made in fixing the capacities of various components of water supply scheme. So it is a future period. It is a future period for which provision is made in fixing the capacities of various components of water supply scheme. capacities of various components. Various components of water supply scheme. Okay? So, simple terms you want to express it as it is nothing but a utility period or useful life period. Utility period, it is also known as utility period or useful life period. So during this period, the system gives the best service. Beyond this period, you can't expect the best. It gives best, then well and good. Otherwise, also we are prepared to replace that system by a new system. So, but we expect the best service from the system till the end of the design period. So till the end of the design period it works, we feel very happy. So after design period, once it crosses the design period, we are ready to replace that old system by a new system. Right? We don't wait till the system fails. So before system fails, we are ready with the new system so that the public service is not affected. Because we need to supply public. We should not stop the supply. So therefore, it is very, very important. So it is also known as utility period or useful life period. ESE exam they will ask mostly. What is the design period of a pump? What is the design period of a pipe that is used in water supply scheme? Something like that. Utility period or useful life period. That's it. This much idea is there, more than sufficient. So total water supply system has got a design period of 30 to 40 years. You can't expect a service beyond that. So water supply system has got a design period of approximately 30 years. Beyond 30 years you can't expect. Or slightly more than 30 years also sometimes you will get. Water supply system has got a design period of 30 years approximately. Normally people write 20 to 30 years. So beyond that you can't expect. Once it crosses 30 years, you should be ready with a new system. You should not go with the old system. Okay? Because old system at any point of time it may fail in giving service to you. That's all. So this is about the first topic, introduction, population forecasting and water demands. And factors affecting water demand, this is not required for GATE exam. Factors, what are the factors which affect water demand? So many factors are there. Theoretical, ESE exam they will ask generally. What are the factors that affect water demand? General things you can see. Factors affecting water demand. Generally, system factors, population factors, city factors, all those things influences water demand. First one is size of the city, size of community. So small communities like villages and all, if you supply water for just drinking purpose, it's more than sufficient. You don't need to meet all of the demands. You don't find public parks, you don't find industries, you don't find software companies in villages. So just domestic purposes supply, people will be more than happy. Whereas big cities like Mumbai, Chennai, Delhi, Calcutta, you need to meet every demand. All of the towns and cities, you need to meet every demand because you find populations living there. Domestic sector is very important. In addition to that, you may find some industries around that community. You may find some commercial establishments, some institutes, some public gardens, public utility, common facilities, which all of us use in a community like gardens and all. Which then we also have got firefighting department, so they also need water. So losses and theft, all these things you have to include. But these are all not required for a small communities. Small community, you don't find industry, you don't find much commercial establishments around you. Therefore, certain things you can cut short. Size of community influences water demand. Then climatic conditions. So where exactly it is located. Dry climate is there, public demand more water compared to cold climate, chilled climate. Chilled climatic conditions prevail, people use less water. That hot climate is there, people use more water. Okay? Chennai and Delhi if you compare, definitely Chennai water demands are more because Chennai located in a hot climate zone, therefore people demand more water compared to Delhi, like that. Climatic conditions influences. Then third one is habits of the people. What type of people living in the community? So their habits depends on whether people living below poverty line or people living above poverty line, rich community or poor community. If more number of people are poor in this community, then demands will be less. More number of people are very rich in community, affluent people are there. Their water habit, their water demands will be different. Therefore, they demand more water. Then fourth factor is pressure in the distribution system. Water supplied under pressure? Pressure in system. So water is supplied under pressure. You know that pipe, it's a piped water supply system. So in the pipes, water rush into the pipes by consuming the pressure energy. So pressure you have to maintain. If pressure is not maintained properly, public they don't get proper water. They don't get supply properly. So therefore pressure need to be maintained. It should not be very high, it should not be very low. If it is very high, then public collect more water than what actually they require. They misuse water. If it is very low, it is very inconvenient to them in collecting sufficient water. So meeting their demand is first priority for us. So we need to meet their quantity requirements, we need to meet their quality requirements. Okay. Then fifth one is type of supply. There are two ways we supply water: continuous supply and intermittent supply. Continuous supply means round the clock supply, 24 hours we supply. Then obviously demands will be more. Continuous supply. Intermittent supply demands will be less. Intermittent supply means supply is made only during the fixed periods of a day. Once in a 2 hours in a day, or 1 hour in a day, or once in every alternate day. Supply is made to the public. Depends. So now mostly in India we have got intermittent supply only. Continuous supply means 24 hours supply. Intermittent supply means supply is only for few hours. Supply for few hours. Remaining period it is empty. No supply of water. Remaining time period, system is not supplying any water to public. It is completely switch off. Okay, that's called intermittent supply. So sixth one is what type of sewerage system is prevailing. Sewerage system is toilets. So toilets with flushing arrangements in the entire community. Flushed toilets are there in the community. Obviously, flushed toilets in the entire community, they consume more water. Partially flushed toilets are there. Some people are using flushed toilets. Some people are not having flushed toilets. Then they go for outdoor for nature call. Isn't carrying a mug full of water. Most of the times, even city like Mumbai, many people they don't have access to the proper toilet. That's why the government of India came with the Swachh Bharat mission, giving loans to the public to construct a toilet with flushing arrangement, because it's too difficult in cities. See now, defecating in open areas, that is very ugly. That is very ugly and unsightly, unaesthetic, unhygienic. So therefore, it is government of India trying their level best to prevent that by giving loans to the public so that they can come up with the toilets with the flush arrangements. So of course, flushing system is there. 30-40 liters we flush after using the toilet. Therefore, more water consumption. Partially flushed system, less water consumption. Then seventh one is quality of water. High quality water we supply. People misuse that water. For every purpose they use that water. So reasonable quality only we need to supply. So quality of water also influences. Then eighth is cost of water. So if you supply water at high price by providing, then obviously they are very cautious about using water. Low price, if you throw away price, if you supply, left and right, they use water, misuse water. Then water meters, policy of water meters. If you provide water meters, then what happens? Like electricity meters, water meters are fixed. Then public have to pay for actual usage. Right? So therefore they cautiously use water. If there is no water meter, then people use for every left and right, they use water. So they misuse the system. So these are the factors which influences water demand. IAS point of view important. GATE point of view, generally they don't ask much theory questions. Okay, that's all. Next, sources of water. So we assessed how much water is required for us to meet all water demands of the public. The next step is you have to identify a source. We already discussed water is not a factory made product. Nobody manufacture water. Water is a natural resource, plentifully available in nature. So our job is what? We have to collect water from the nature and supply to the public. So where it is available? What is available in the nature in the form of water resources. Okay. Sources of water broadly classified into two categories. One is surface waters. Other one is subsurface water. So GATE exam point of view, supposed to have idea which is good, which is bad, which is best for your community. So many sources are there around you. You have to make a choice, right? Surface water, again, there are so many things are there in surface water. So what are the different surface water sources? Surface water sources further classified into two categories: running water bodies and standing water bodies, static water bodies otherwise. So one is ponds and lakes. Second one is streams and rivers. Third one is reservoirs. Okay, these are the surface water bodies. So what is a pond or lake? Pond and lake, both of them are right. Both of them are same. They are the depressions formed in the ground. When these depressions collect water, resulting in formation of pond or a lake. These are the ground depression. This is a ground. So suddenly you will find a large depression here. When rain happens in a catchment, the rain water slowly join these depressions, finally accumulate there, resulting in formation of pond or a lake. Okay, these are the depressions formed in the ground. When these depressions get filled with a runoff from the catchment, then that result into formation of pond or a lake. This one is called pond or lake. So pond is a small depression, lake is a large depression. The small ground depression it is, small in size it is. Lake is a larger in size. Small is small in size, ground depression only, and lake is a large in size. And what is important for exam point of view regarding these sources is quality wise which is good, or quantity wise which is good. So quality is superior compared to other surface sources. Quality is superior because standing water, it acts as a natural sedimentation tank. So all the impurities, dirt particles present in water settle down, therefore yield good quality water. But quantity is less compared to other surface sources. Quality is good, but quantity is less compared to streams and rivers. I'll write quality. Quality is good and quantity is poor, less compared to streams and rivers. Compared to streams and rivers, this quality of pond water, lake water is good, but quantity is less compared to streams and rivers. Therefore, for ponds can be used for small communities. Small communities, they can think of ponds. Large communities, lakes can be used even for large communities. So lakes can be used for large communities. City like Mumbai is there, Mumbai. The Mumbai population is 2.5 crore. The total Mumbai is fed by two lakes. There are two lakes in Mumbai. One is Powai Lake, the other one is Virar Lake. Those two lakes are so much to Mumbai. So 2.45 crore population's water demand is met by those two lakes. So that's why they are very, very important for Mumbai. They protect those lakes like anything. So they can answer water requirements of any community lakes. But ponds can answer water requirements of small villages, small towns, etc. You can't depend on for large communities. Okay. Then streams and rivers. So streams and rivers, both of them are running water bodies. They are quality wise poor, but quantity wise they are very, very good. Quality wise, why they are poor? Because they are running water bodies, there is a turbulence, does not allow these dirt particles and all settle down in water. So dust particle and all keep on moving along with water. Therefore dirty water will get. Dirty water will get, but more will get. So more water is required for, then meeting water demand is the first priority. Therefore we mostly go with the streams and rivers. So the streams and rivers are natural channels formed in the ground. Natural channels. They are the natural channels formed in the ground which collect runoff from the catchment and carry. Runoff water from catchment and carry. Carry that water from place to place. So these are the running water bodies. So this is a river. Rivers are the best. So river flowing here. So this is the best source. Water will be flowing in a river. So many communities they depend on. Suppose for Ganga river you see, river Ganga you see. So there is first big city is, what is that first big city? Haridwar. So Haridwar is there on the banks of Ganga. Then Allahabad. Like this, so big communities are there on Ganga river, on the banks of Ganga river. Allahabad. Then further if you go there, you will find Varanasi. Like this, all big cities are there on the fringes of Ganga river. So they are the best sources, Ganga river. This is. So they are the natural sources because they meet water demands of any community. They are the best. Okay. There are two types of stream and river. Stream is a small channel, river is a big channel. Stream is a small channel, size is small, smaller in size, and river is a big channel. So many small streams join into a big river. Many small streams combine together, finally ultimately result into a river. River bigger in size. So this for small communities, they can depend on them, like towns, villages. They can depend on streams. So villages and all, they can depend on streams, villages, towns. So any community can depend on rivers, towns and cities. They can comfortably depend on river water. So again coming back to the streams, there are two types of streams and rivers. One is called perennial, the other one is called non-perennial. So in perennial streams, flow is available throughout the year. Flow available all 365 days in a year. Whereas non-perennial are seasonal. Flow available only in rainy season. Rest of the period, the stream become dry. Only in rainy season. Rest of the time, they become dry. They are called non-perennial. So perennial are the reliable sources. Perennial sources are more reliable. Okay, for water supply of a community. So you can depend straight away on perennial source. Okay, non-perennial they are less reliable, but there is a to see that it also more reliable. Something you have to construct. That something is nothing but a reservoir. Okay, quality wise compared to ponds and lakes, quality is inferior, quality is superior, quantity is superior, quality is poor, but quantity is good. Quantity is very good, it is. quantity wise it is very, very good. Huge amounts of water are available, so that's why they are reliable. So non-perennial sources, when depending on them, then you have to construct a reservoirs. So reservoir is nothing but a water bank. Okay, so reservoir is nothing but an artificial lake. It is an artificial lake, constructed source. Constructed on non-perennial stream or a river. So when you are depending on non-perennial stream or a river, you have to construct a reservoir. Reservoir is nothing but a water bank it is. So river is flowing which is non-perennial. So this is a rainfall season, you will find more water. Therefore what we do? We stop water by constructing a wall across it. So when you construct a wall across the river, there is a river flowing, carrying water. So then there is a large pool of water is created on the upstream side of the wall. This is known as reservoir. Large pool of water is created on the upstream side. So reservoir is formed. This is called reservoir. So from this reservoir, so we store water when more is available. That water we use whenever need arises. Dry season you don't find much flow in the river, but because of the wall which has stopped the water and stored the water, that water we can withdraw and use it. So that's how we can manage. So reservoir is constructed and used. Understood? This is about. So among all these sources, this quality wise also good, quantity also good, because it's artificially created source. So therefore quality also it matches, quantity also it matches. So if you compare all these sources, streams we depend more on rivers. Perennial rivers are more reliable because huge amounts of water is available. So any type of community without any second thought, they can depend on perennial rivers. Okay. Next, coming to subsurface sources. Coming to subsurface sources, we have got three kinds of subsurface sources. One is called springs. Second one is infiltration works. Third one is wells. Okay, three kinds of things are there. Normally we keep subsurface source as a standby source. Kept as standby source. Main source is always surface source. We always keep subsurface source as standby. In the case of absence of surface sources, then only we use subsurface sources. Otherwise, it is used as a standby, reserve source. Only in emergency and emergency we use, because all subsurface sources water is very expensive compared to surface sources. So let us see. What is spring? Spring is nothing but a natural outflow of groundwater. When water flowing inside the ground, when there is no proper extension of the ground, water get out of the ground get punctured and water start oozing out of the ground, resulting in formation of a spring. So mostly you will find the springs in mountain regions. Okay. So spring is a natural outflow of groundwater. Natural outflow of groundwater. Suppose this is a ground. For example, this is a ground. So there is no extension of ground. Suddenly there is a ground. So water is flowing freely inside the ground in the form of water table. Water is flowing inside the ground. So in this direction. Suddenly because of there is no ground here, then what happens? This is a leading water, this is trailing water. Trailing water is pushing the leading water. There is no option left with this water. Therefore what happens? Ground get punctured here. Then water start oozing out of the ground, resulting in formation of spring. We call them as gravity springs. This is spring. Natural outflow of groundwater. This is a ground. From ground, water get out of the ground, resulting in formation of a spring. Isn't it? Springs yield extraordinary quality water. Extraordinary water you will get. If you go to Himalayas and all, so you will find most of the springs, even they have capacity to cure skin diseases. So they contain high amount of sulfur. So sulfur is good for skin. So extraordinary quality water. Quality wise they are superior, but quantity wise only in mountain region people can depend on this source. So yield superior quality water in less quantities. Quantity wise they are poor. So springs yield superior quality water in small amounts. Springs yield superior quality water, extraordinary quality. Quality wise it are very good. No source can match in terms of quality with the spring water. Superior quality of water in small quantities. Quantities are less. Therefore, they are suitable only for small villages, small hamlets, small towns in mountain region. Therefore, they are suitable small villages, hamlets, small towns in mountain region. That's all. This much idea is there, more than sufficient. So next, infiltration works. Infiltration works. So normally infiltration works are used by the small communities where they don't have money to draw water from a river. Straight away from streams and rivers you want to collect water because they yield dirty water. Dirtiest water you will find in them. So before we supply that water to the public, water should be purified. That cost of that purification is very high. But small villages and towns, they don't have enough funding with them, enough money with them. Local bodies are not that much rich. Therefore, the treatment is not affordable to them. Treatment is very expensive to them. In such case, so they depend on infiltration works. So big cities, big towns, big towns and big cities where local body is very rich, even though the rivers they yield dirty water because they use technology to purify that water. So because they have got money, therefore meeting the water demand is first priority to them. They don't mind in investing money in treating the water. But whereas small communities where local bodies are not that rich, so treatment is not affordable to them. When treatment is not affordable to them by drawing water from streams and rivers, then there is no other option left with them other than using infiltration works. Understood? Infiltration works. There are two types of infiltration works you can think of. One is infiltration galleries and other one is infiltration wells. So infiltration works are constructed at the bank of a river or bed of a river to tap seepage water from the aquifer. Okay, to tap seepage water from aquifer we construct infiltration works. So normally aquifer means sandy strata. Sandy strata. Sandy soil. You will find so much sandy strata is there. That sandy strata act as a natural purifier for them. So it purifies the water. Purified water if you collect, then you will get extraordinary quality water. Straight away can supply to the public. No treatment is required. That's how they can cut down the purification cost, treatment cost. But initially you have to construct infiltration works. Okay. So there are two types of infiltration works. One is called infiltration gallery. Second one is called infiltration well. Infiltration wells. Both of them are used for same purpose. Only construction features are different. Gallery is a horizontal tunnel dug at shallow depth at bed of a river or bank of a river. Infiltration well is a vertical hole drilled at bank of a river or bed of a river to tap seepage water. Both of them are used for same purpose. Gallery is a horizontal tunnel. It is an horizontal tunnel dug at shallow depth. It is a vertical hole made in the ground to tap seepage water. Both of them are used for same purpose. So gallery we see, so this is a river. There is a river. Assume there is a river, this is carrying water. This is a river. Okay, assume. So you can construct this gallery. This is a gallery, infiltration gallery. Tunnel it is. Tunnel shape could be anything, rectangular tunnel or parabolic tunnel or oval shaped tunnel, whatever it may be. So what happens then? So this tunnel start collecting this seepage water. So it will go and accumulate here. Or if this is called bank of a river, this is bed of a river. At shallow depth, this is a bed of a river. This seepage water go like this and finally join this tunnel. This tunnel is called infiltration well. These are called infiltration gallery. Infiltration gallery. Horizontal tunnel dug at shallow depth 2 to 5 meters below the bed of a river or bank of a river is known as infiltration gallery. These are called infiltration galleries. If you see the plan of this one below ground, so it is like this. So it always collects water from sides. So water will be rushing towards the gallery. Water will be flowing like this. And finally this water accumulate in the gallery and we collect at one common point called sump. Sump would be there at some point. This is a sump. So all this water finally accumulate in a sump. This is a infiltration gallery. This is a plan of infiltration gallery. Cross section, you see, this is a cross section. This is cross section. This is a plan. So finally water, wherever it is collected, it rushes towards center of the sump, towards sump. Finally water accumulate here. From there we pump out. That's how it appears. This is called infiltration gallery. Okay. Infiltration wells, you see, their orientation is different. Gallery is horizontally oriented, wells are vertically oriented. Same. To collect same way, we collect water. It is a river. So wells always collect water from bottom. Gallery always collect from top sides. This is a well. Either you can have a bed of a river or bank of a river. This is a river. Okay. Assume. So water will rush and finally accumulate in this well. It always collects from bottom. Well always collect water from bottom. Gallery always collect from side. That's how we can identify whether it is a well or in the cross section. This is a cross section of infiltration well. Because wells are small hole made in the ground, so because to collect large quantities of water, series of such wells you have to construct along the length of a river. So this is a river. Assume. So this is a plan of a river. So there where we construct this, either at bed of a river or a bank of a river. Series of such wells. These are the plan of infiltration wells. You can have it. This is a bed of a river, bank of a river, or otherwise this is a bed. Inside the river also you can construct. So series of such wells are constructed, and all these wells will pump water into a common sump known as jock well. That common sump which we use known as jock well. This is called jock well. Jock well is nothing but a sump. So infiltration wells deliver water into jock well. From there we pump out water. This is called jock well. Jock well is nothing but a common sump kind of thing. Okay. Series of such wells are constructed. So series of infiltration wells are constructed to get the desired quantity. Quantity also important, no? That's how. That's why so many such wells you need to construct to collect that seepage water from the aquifer. So what is there? This is sandy strata. Between these two, what is there? sandy soil is there. When water passes through sandy soil, then what happens? Here, what is there between these two? Sandy strata is there. Sandy strata, sand. Okay, sand is there. When water passes through sandy strata, naturally, sand is a good filtration material. So water is filtered. Naturally, water is filtered. That's how it happens. Same in the case of this one also. Between these two, what is there? Sand is there. So water has driven through certain distance through sand strata before it is collected. Right? So that's how when it passes through sand strata, so water is purified. So we get high quality water. That high quality water we can supply to the public. No further treatment is required, straight away we can supply, because sand is a very good filtration material which collect and which react and retain impurities. Sand is a good filtration material. Sand is a natural filter material, filter media. So which react and retain impurities in water. Impurities in water. Bad things present in water retained by sand and yield impurity free water to the sump. Otherwise that into the well or gallery. That's how it happens. Sometimes design of infiltration gallery is not required for this exam. IAS conventional, sometimes they will ask. So this is about infiltration wells. Understood? What is the difference between gallery and a well? Gallery is a horizontal tunnel dug at shallow depth. Well is a vertical hole drilled at shallow depth. That's all. Nothing will be there. There is no much difference. Both of them for same purpose. Next, coming to wells. Well is nothing but a hole made in the ground to tap groundwater. Groundwater is different. Infiltrated water is different. Infiltrated water will find, where you will find seepage water. Seepage water is nothing but infiltrated water. Right? To tap seepage water. Seepage water also known as infiltrated water. Seepage water infiltrate into well. Okay? So you don't find infiltrated water everywhere. So if at all you want to construct a infiltration wells or infiltration galleries, you have to go to the river bed or river bank, not everywhere. But wells can be have anywhere. So well is a vertical hole made in the ground to tap groundwater. Well is a vertical hole made in the ground to tap groundwater. Groundwater is different, seepage water is different. To tap groundwater. So there are two types of wells. One is open wells or dug wells. Second one is tube wells or bore wells. So these are different. Infiltration wells are different. Infiltration wells you can have only at bed of river, bank of river. But these wells you can have anywhere. Okay? Wherever ground is there, there you can try for groundwater. So let us see open wells or dug wells. So the size means diameter. The diameter of these wells are normally, right, it is 2 meters to 9 meters. And depth is normally not more than 17 meters. Beyond 17 meters they are uneconomical. Okay? Uneconomical because lead and lift increases. You have to make a drill, you have to make a hole in the ground. So lead and lift excavations become costly. Costly to excavate. Lead and lift increases. So depth should not be more than 7. It is limited to 17 meters. Up to 17 meters you can go. So diameter is normally 2 meters to 9 meters. Then yield also limited. Yield means discharge. Discharge is limited to 2 to 6 liters per minute. Limited discharge you can have. So it taps only top water bearing strata, top layers of the water bearing strata. Top aquifer only it can tap. Tap water only from top aquifer or at most next aquifer. So there are two types of open wells. One is, it is not based on depth, shallow open well. Second one is deep open well. Shallow open well and deep open well. Shallow open well always collect water from the aquifer surrounding it, the top aquifer surrounding it. Deep open well collect water, rest on the impervious strata and start collecting water aquifer lying below impervious strata. Okay, that's the difference. Sometimes a deep open well may be shallower than shallow open well. It is not based on depth, it is based on the way the well is drawing water from the ground. Shallow open well draws water from the top aquifer. Draw water from surrounding top aquifer. So draw water from this well, rest on impervious strata and draws water from the aquifer lying below impervious strata. Rest on impervious strata. In Hindi, the people call it as mota layer. North India, people call it as mota layer. Rest on impervious strata. Impervious strata means clay strata or rocky strata, something like that. Impervious strata. Draw water from aquifer lying below impervious strata. That is the difference. So it is not, people misunderstand. People think that it is a depth. It is not a depth. This is a ground. So ground contains pervious strata and impervious strata. Top one is a pervious strata. Next you will find impervious strata. Then again pervious strata. Again impervious strata. Ground is structured like this. This is pervious. This is impervious. Again pervious. Again impervious. Again pervious. Ground is structured like this. This is pervious. Again impervious. Pervious means aquifer. Impervious means aquiclude or aquifuse. Aquiclude or aquifuse. So there is a groundwater table here. If it is shallow open well is dug at shallow depth. So this is not, then it is not depth, sorry. Shallow open well, this is a shallow open well, right, which collect water from the top pervious strata. This is aquifer. Here groundwater is there. So from here it collect water. This water rush into this well. This is called shallow open well. Whereas deep open well rest on impervious strata. This is rest on impervious strata and it's get water from where? The aquifer lying below it. So small hole is made into this impervious strata. It doesn't collect water from this top aquifer. It collect water from impervious strata lying below it. A small hole is there. So then water from here. Here also water is there. This water is collected. So this water rush into this well and finally accumulate there. So it collects water from the aquifer lying below impervious strata. This is impervious, this aquifer. This aquifer is called, what is this aquifer is called? Hydrology studied. What do you call this aquifer? This aquifer is called, right? What is this aquifer? What is this? All these aquifers only. These are also aquifer. So, what is these aquifers are called? Top aquifer is called? Top aquifer is called what? Confined or unconfined? This is unconfined. The bottom, the remaining aquifers which will lie below ground, deep inside the ground are called confined aquifers. confined between two impervious strata. These are the aquifers. These are the confined aquifer, this is unconfined aquifer. Understood? So it's sometimes a shallow open well may be deeper than deep open well. This is deep open well. Suppose this impervious strata is inclined something like this. This impervious strata is inclined in the ground. This is a ground. So if you construct a shallow open well here, there is a groundwater flowing here. Then if you construct a shallow open well, it can go up to this. Whereas a deep open well somewhere else, you construct somewhere here. Then what happens? Depth wise, you see, which is more in deep. So this collect water from here. So this collect water from here, this water will go and accumulate there, and this start collecting water from here, this water will go and accumulate there, isn't it? So depth wise if you compare, this is deep open well, this is shallow open well. It is not based on depth. Sometimes shallow open wells may be more deeper than deep open wells. So it is the way it collects water. So shallow open wells collects water from tap aquifer surrounding it, whereas deep open well collects water from rest on impervious strata, collects water from aquifer lying below impervious strata. So that's the difference between shallow and deep. Okay. Next, coming to tube wells or bore wells. Coming to tube wells or bore wells, normally diameter of the tube well is 15 to 30 centimeter, very small in diameter. We have got a drilling technology with us. We can drill this hole to any depth, and depth normally varies anywhere between 20 meters to 70 meters, and sometimes even more than 70 meters also. Some places. Okay. Generally, the yield is little bit more, so you can have 15 to 45 liters per second. Compared to LPS means liters per second. I'll write here. Oh, sorry, liters per second. Sorry, it is not liters per minute. Liters per second. Sorry. You can also write LPS. Understood now? Already I wrote there, I can remove here. So more water you want to collect, you have to drill. More number of aquifers you have to tap. So tube wells or bore wells are called. Okay? So again, we have got two types of tube wells. Based on depth, they are classified into two categories. Based on depth of tube wells, they are classified into two categories. One is shallow tube well. Second one is deep tube well. Shallow tube well, so depth is limited to 20 meters to 70 meters, whereas deep tube well depth is more than 70 meters. Okay, based on purely depth this is. Then there is one more classification related to tube wells or bore wells. Based on the way it collects water, based on water collection from aquifer, they are classified into two categories. They are classified into two categories. One is cavity type tube well, other one is strainer type tube well. Strainer or starter type tube well. Okay. Cavity type tube well collects water from the aquifer which is lying deep inside the ground, okay, only from one aquifer by making a cavity at its bottom. Suppose assume this is a ground, so which contains alternate layers of pervious and impervious strata. This is impervious strata, again pervious strata, again impervious strata. Assume like this ground is there. So top is pervious strata, again impervious, again pervious, again impervious, again pervious, again impervious. Whereas cavity type tube well is driven into ground such that a cavity is made at the bottom, big cavity happens at bottom. This is a well. Cavity is nothing but a big hole. So technology is there to drill a big hole at its bottom. This is called cavity. So these holes start collecting water from this aquifer, this portion of aquifer. So water in this aquifer rush into this aquifer. So water rush into this well from here. This is the water. And water finally accumulate in this well. So no water is collected from this region, Here also water is there, but it doesn't collect this water. This is also aquifer. This is also aquifer. But this aquifer it collect water. Only one aquifer it can tap by making a cavity at its bottom. This is called cavity type tube well. This is called cavity type tube well. Cavity type tube well always collect water from bottom. Okay? Whereas strainer type tube well collects always water from sides. That's the difference between them. If we extend and see, same ground, right? A strainer type tube well tap more number of aquifers because it collects water from, this collects water from where? Sides. So different zones, water available inside the ground, it can start collecting that water. This is how it appears. Just to give idea, people often confuse when they ask questions, they don't answer. Especially IES exam, they are asking questions related to them. Okay? This is a cavity type tube well. So this cavity type tube will always collect water from sides. So therefore, it can tap more number of aquifers. So water will be there here. So it collect this water also. It collect water from here. Okay? This water also it collect. This water also it collect. This water also it can collect. It always collect from sides. Bottom is completely plugged with cement concrete. This is completely closed. Closed with cement concrete mortar. CC. Cement concrete. Plugged with cement concrete. So it always collect water from sides. Then how it can collect from sides? There are the pipes driven there. Okay? So if we drive, wherever impervious strata is there, there will drive plain pipe. Wherever pervious strata is there, there will drive slotted pipe or strainer pipe. Okay? This is called strainer or slotted type tube. This is strainer or slotted type tube. So how it is driven? So wherever impervious strata is there, there will find plain pipe. So this is a plain pipe. Wherever pervious strata is there, we drive slotted pipe or strainer pipe. Slot is nothing but a holes. On the periphery of the pipe, you will find small holes. This is plain pipe. This is slotted pipe. Slotted pipe. So slotted pipe means what? These are the slots. You will see the slotted pipe. So if you see the pipe, on the periphery of the pipe you will find slots. Either circular holes or rectangular holes you will find. These are the slots, openings. If you assume that this pen is a pipe, on the circumference of the pen, right, along the length of this the pipe, everywhere you will find holes. So through these holes, water rush into this. These holes are called what? Slots. Slots are nothing but openings. These are the openings. This is a pipe. This is a slotted pipe or strainer pipe. Slotted pipe. So, to this what we provide? We provide a wire mesh. It is bounded with wire mesh. One wire mesh is bounded. The purpose of providing wire mesh is to prevent entry of sand particles into. Sand also move along with water. To prevent that sand particles getting into well. So sand slowly start accumulating in the well. What happens? That hole is filled with sand. It is completely subsided. So therefore, to prevent that, we provide one strainer. Strainer is nothing but a wire mesh. Strainer is nothing but a wire mesh. So this wire mesh is wrapped around the pipe. Wire mesh is wounded around the pipe like this. So to the holes on the top of that pipe, we wound or wrap wire mesh surrounding it. That wire mesh prevent entry of sand particle. Strainer nothing but a wire mesh. Prevent entry of sand along with water. So sand also try to get into well, so it doesn't happen because strainer stop the sand. That's how it appears. So wherever pervious strata is there we provide strainer pipe or slotted pipe. Wherever impervious strata is there we provide plain pipe. Plain pipe, no holes. This is a plain pipe. No holes, without holes. Either you can have slotted pipes, rectangular openings also sometimes we provide. Slots could be rectangular also. Openings could be small holes, rectangular holes, something like this. On the periphery of the pipe. They are called slots. They are called slots. So the top of the slots will wound with wire mesh. Wire mesh is wounded. This wire mesh is called. So slots could be circular, slots could be rectangular. These are called slots. Slots are nothing but openings. Okay? Hope it is clear to you. I hope it is clear to you, all of you. Any doubt is there, you can ask me. You can type in the comment section. Okay. So coming to the groundwater kinetics you have to learn. Sometimes they are asking questions in exam. Whatever may be, either it is a strainer type, slotted type, or cavity type, or deep open well, or shallow open well, or deep tube well, or shallow tube well, whatever it may be. So all this concept is true. So groundwater yield or groundwater movement, groundwater yield, groundwater movement, that depends on Darcy's law. Groundwater flow or movement and groundwater yield governed by Darcy's law. What is the Darcy's law? V is equal to K into I. This is called Darcy's law or Darcy's equation. This is called Darcy's equation. V is equal to Ki. What is V? V is nothing but seepage velocity. Oh, sorry. V is discharge velocity or apparent flow velocity. Apparent flow velocity, where K is equal to permeability of soil, coefficient of permeability. This is soil property. So depending upon this, how much water we can collect, that and all we work out. Soil property, how much water soil can yield, that depends on K value also. V is equal to Ki. Okay, where I is equal to slope of hydraulic gradient line, or nothing but slope of, in our language we call it as slope of water table. We call it as slope of water table. Slope of water table. Okay, so I is equal to slope of water table. But actual flow velocity through ground is called seepage velocity. Actual flow velocity or seepage velocity is known as VA. We denote it by VA. So actual flow velocity VA is equal to apparent flow velocity by porosity. If you divide by porosity, you get actual flow velocity or seepage velocity through ground. So where N is equal to porosity of soil or porosity of aquifer. It is also ground property. So K also ground soil property, N also soil property. So soil property influences the yield. So not only this, we also work out yield from the aquifer. So yield from the aquifer we work out by using equation dot Q is equal to KIA. 2 minutes, Suresh. So groundwater yield from aquifer is equal to, or groundwater discharge, or groundwater yield we call it as, so we work out by using equation Q is equal to KIA. Area into velocity. Velocity V is equal to Ki, area. Extra thing. What is A here? K and I is known to you already. Right? What is A? Area perpendicular to area of aquifer perpendicular to flow direction. Area of aquifer perpendicular to flow direction. Okay, that's called A. So today I'll stop here. So before I stop here, then you can see next class we'll say solve some problems related to aquifers. Okay, they're asking questions in exam. So you can subscribe to Unacademy. You can take Unacademy subscription. So use my code. My code is GATE Civil. My code is GATE Civil, and you can take some concession, 10% concession they will give you. They have launched this course. So go through these slides. Subscribe now. Take my code GATE Civil. We try to learn as much as we can. Many subjects we deal here, all the subjects of civil engineering from expert faculty. So learn properly and excel in exam. Okay? This is the code. This is the subscriptions. Different subscriptions are available. So for different time periods they are offering this course. Then today I'll stop here. Thank you very much. And again tomorrow I'll not be taking class. Again we'll meet on 10th 8 p.m. 10th 8 p.m. 8 to 9:30 I'll take class. Again we'll meet on 10th. Thank you very much.